Jai Hind everyone. Myself, Dr. Ajay Pratap Singh, and I am working as an associate professor and Department of Mechanical Engineering at Ajay Garvin College, Ghaziabad. And I teach here in the final year subject at the Renewable Energy Resources, KOE 074. It's affiliated by the no, Dr. APJ Abdul Kalam University, Lucknow. And today, I'll teach here for the solar energy system. So, solar energy is the part of we can say the renewable energy, and we can use the solar, the sun power, we can say, and it's freely available. So, I'll discuss the how to solar working, and you can see in case of the solar energy, you can see some the solar plates inside backside. So you can see there are some solar plates in there. So how the solar plates is installed and which type of the which orientation is required for the installation of the solar power solar plates. And I'll discuss the one by one. So for the today topic, I'll discuss the solar radiation is there. Then the flat plate collectors and their materials and the application and performance I'll discuss during this. And third, in the focusing of the collectors and their materials, application and performance. So basically, the design of these materials with and what is the layer by layer, which, how many layers in this the solar plate. I'll discuss the one by one. So we can say the solar, basically everyone known we can use the solar power through the sun, right? And sun is the freely available to everyone. So we can use the solar thermal power generation system, use the miner to mirrors to collect the sunlight and produce the steam by the solar heat to drive the turbine or for the generating of this power. So this system generates the power by the rotating a turbine like the thermal and the nuclear power plants, and therefore it's suitable for the large scale the power generation. Recently, government is also the India UP sorry you can say the government of India has launched the scheme the Pradhan Mantri Suryodaya Yojana, and that is that the 1 crore people are installed the rooftop use the solar power, and every we can say the sustainable power and sustain the home for this electricity. So you can say the solar radiation is electromagnetic radiation ranging from you can say the 0.25 to 0.25 to 4.5 million to wavelength, including the near UV ultraviolets, visible lights, and near the infrared radiation. So common units of measuring of the we can say the measuring for the electromagnetic radiations or wavelength. So the 1 angstrom equal to 10 power minus 10 meter, then 1 nanometers equal to 10 power minus, and then 1 micrometers you can say that 10 power minus 6, then 1 millimeter that's the 10 power minus 3 meters, and then 1 kilometer equal to 1000 meter. So there are some units to the electromagnetic radiation wavelength. So solar radiation, you can say the sun is the most easily source of the energy, and this energy is spread over a long span and small fraction in our ancient on the earth. So its outer visible layer is called photosphere, having a temperature of 6000 degrees centigrade, and above the photosphere there is a transparent layer of the gas known as the chromosphere. So we can say the solar radiation is the radiant energy emitted by the sun from the nuclear fusion reaction, and that create the electromagnetic energy. And after that, the spectrum of the solar radiation is close to that of the black body, which with we can say the temperature about the 58,000, 5,800 Kelvin, and about the half of the radiation is in the visual short wave part for the electromagnetic spectrum. So in the solar radiation, we can say the include the visual lights, ultraviolet light, infrared radio waves, and X-ray and gamma ray radiation in a one way to the transfer of the heat. So solar radiation, you can say the solar position with the respect of to the Earth. the sun is the most easily source of energy, and this energy is spread over the long span. So you can say the ancient or visible layer and the photosphere, the temperature is 6,000 degrees centigrade. So above the photosphere, there is a transparent layer of the gas known as the chromosphere, and then these are the sun statics. You can say the mass of it 1.98 into 1030. Then that is the equatorial radius in the kilometer 69500, then mean density 1.41, then mean surface temperature, then hydrogen, oxygen, helium, neon. In the percentage, you can see 92.1% is the hydrogen, 0.061% from the oxygen, helium is the 7.8%, nitrogen is the 0.0084%. Then we can say the carbon is the 0.03%, neon is there, iron is there, silicon, magnesium, sulfur, and then all others there. So we can say that is the solar energy passes through the region on its way out from the center for the sun. So the solar radiation is the electromagnetic radiation emitted by the sun, and this radiation can be converted into useful form of the energy such as heat and electricity, but by the different type of the technology. And the electromagnetic radiation, you can say, emitted by the sun, so a wide range of the wavelength, and it can be divided into the major region, the ionizing radiations, X-ray and gamma rays, and non-ionizing radiation, UVR, visible and infrared radiation. And the highly injurious radiation does not penetrate to the Earth atmosphere. So you can see the invisible the wavelength is the ultraviolet range. So violet range 400, blue visible range is the 425, the green 490, yellow is the 575, and then the orange the 555, then red is the 650, then invisible and again infrared is the 700 degrees centigrade and 14,000. So these are the some non-penetrable Earth atmosphere and highly. So solar radiation, you can say again, the reaches the surface of the Earth without being scattered and reflected from the somewhere. It is called the direct beam solar radiation. So while the sunlight that reaches the surface of the Earth by the passing through the atmosphere gets some of it to the of this portion is absorbed, scattered, and reflected by the air molecules, water vapor, dust, and pollutant. Such type of radiation is called diffuse solar radiation. And the sum of the direct beam solar radiation and diffuse solar radiation called the total solar radiation. So you can see the surface of the Earth. These are the surface of the Earth, and you can say that is the reflected back to the space here, then the reflected back by the surface there, the terrestrial region is there. So diffusion region there, diffusion scattering is there, then extra transition, atmospheric absorption, then direct radiation. So there are some you can say the direct, diffused, and total surface radiation inside the surface of the Earth. So you can say find out the sun and Earth angle. So we can say the latitude is there, declination is there. So our angle, altitude angle is required. So during this, the latitude is the phi. You can say that denoted the latitude phi of the location is the angle made by the radial line joining and the location to the center of the Earth with the projection of line on the equatorial plane. And you can say that it can be vary between minus 90 degree to plus 90 degree for the northern hemisphere latitude the positive. So our angle, that is the omega, it is the angle which we can say through the Earth must be rotate to bring the meridian of the plane to directly, you can say, under the sun. And this we can say the our angle is 0 a solar moon, and negative in the morning and positive in the afternoon for northern hemisphere in India, and vice versa to southern hemisphere in the Australia. So omega, you can say the 15 st minus 12 where the st is the local solar time. So again the next angle is the declination angle that is represented by the delta, and it is you can say the angle made by the line joining the center of the sun and the Earth with its projection on the equatorial plane. So the decline angle varies from the maximum value plus 23.5 degrees centigrade or June 21 to minimum value of minus 23.5 December 20. So the delta, you can say 23.45 sin 360 into 240 284 n upon 2365 n the number of the year. So altitude angle is again represented by the alpha. So it is a very vertical angle. It is a vertical angle between the projection of the sun rays and the horizontal plane and the direction of the sun in the rays. So you can see here in this figure you can find out that is these are the phi, right? Delta, omega, alpha. So these are the angle is there. So zenith again you can say the zenith angle theta z the complementary and the angle of the sun altitude angle, and it is the vertical angle between the sun ray and the line perpendicular to horizontal plane through the point. So the delta is equal to pi by 2 minus alpha. So surface slope, you can say this is the angle between the plane surface under the consideration and horizontal. It's taken to be positive and surface slope towards the south and negative surface along the towards the north. So we can say the equator is there. So long it horizontal our angle by the sun and decline. So equatorial is there, and you can see that is a different according to position of the earth. You can find out the alpha, delta, omega, theta, and beta also. So the sun angle earth, you can see the theta and alpha. So the solar azimuth angle gamma, as we can say, it is the represented by the gamma as, and it is the angle in horizontal plane between the line due south and projection of the beam radiation on the horizontal plane. Thus, it gives the direction of the shadow cast in the horizontal plane by the vertical rod. So, sunrise, you can say sunset, and day and day length. Day length is represented by day length is represented by the end, and the hour angle corresponding to sunrise and sunset horizontal surface and day length can be calculated. The following equation you can say. So these are the equations have been given. They are the standard equations given, and you can calculate it. So measurement of solar radiation, you can say the instrumentation of the measuring solar radiation are two basic types. One the variometer, pyranometer, and sunshine recorder. So we can say if you discuss the variometer, so you can say and the instrument for measuring the solar radiation from the sun and from a small portion of the sky around the sun, the beam radiation at normal incident. The panometer is an instrument to measuring the total hemisphere solar, the beam plus diffuse radiation, usually on a horizontal plane, a horizontal surface. Then sunshine recorder. The sunshine recorder is used to measure the hours of bright sunshine. The hours of the bright sunshine, that is the time in which the solar disk is visible, is of use in estimating the long-term average of solar radiation. So the solar collectors, you can say the device. It is a device to collecting the solar radiation and transfer the energy to the fluid passing in contact within it. And the surface of solar collector is designed for high absorption and low emission. And there are two types of the solar collector. One is the concentrating we can say the flat plate solar collectors, and second is the focusing type the solar collector, and concentrating you can say. So the focusing again there are variation type, the parabolic reflector type, parabolic through connector concentrator, frictional lens, then parabolic disc, then distributed elastic point, and compound parabolic connector. So you can say the which principle are used. So the most of the energy we receive from the sun comes in form of the light, a short wave radiation, not all of which is visible to the human eye. So we can say when this radiation strikes a solid or liquid, it is observed and transformed into the heat, and the material becomes warm and store the heat. The conduct it's so flat plate solar collector, you can see here in the figure. There are some flat plate collectors, And the flat plate solar collectors are probably the most fundamental and most studied technology for the solar power domestic hot water system are used, right? The overall, we can say the idea behind this technology is pretty simple. The sun heats a dark flat surface which collect as much energy as possible, and then the energy is transferred to water, air, and other fluid for the further use. The flat surface, again, the collectors are probably the most fundamental and most situated energy. Uh, we can say the solar of the full flat plate thermal installation is there. So we can see that these are the some main component or type of typical flat plate solar collector. There's black surface, glazing cover, then the tubes and the support structure. So we can see here the black surface. The black surface, black plate is there. So black surface, you can say the absorber. You can see that is the black surface. So black surface, the absorbent is the incident solar energy. These are the solar, right? The solar energy is absorbed. Then glazing cover, you can see basically the transparent layer, that layer that transmit the radiation to the absorber, and but prevent the radiative and convective heat loss from the surface. Third one, you can say the tubes, so containing the heat fluid to transfer the heat from the collector. Support structures, and to protect the component and hold the place, and the conveying the insulation and side the bottom of the collector to the reduce the heat losses. So these are some system there. A transparent system is there. So the black plate is there, the observer is there, the transparent is there, and that these inside that is, you can see that is blue color represent the fluid tubes. These are tubes, you can say, the containing the heat fluid to transfer the heat from this collector. The flat plate collectors are basically into two type category. One is the water or liquid heaters, and the other air heaters. And we can see the water liquid heater, again they divide into three categories: the pipe and fine type, water and sandwich type, and the semi sandwich type. Air heater is again the fin type, metal type, matrix, and we can say the corrugated the plate with the selection of the surface. So again, these categories divided into three types, right? So flat plate solar collectors, you can see there are the observer. You can see different types of this flow. The one PV, the absorber is there. Then the airflow inside the insulator is there. Again, the glass cover. Second case is there. The glass cover is there. Airflow inside the PV mount. Then absorber, and then again here the difference is there. That only the glass cover is put in the upper side of this the absorber. So again here you can see the fins picks up inside solar plate. Again insulator, so there are difference here, and the fins are used. Here you can say the V grooves in the PV modules, and here you can say the round tubes are used for the insulator. So there are PVM modules is put inside. So there are different day by day, you can say the technology increases, and different types of the condition, you can say the different type of solar plate has been designed, and it's used on the basis of these applications. So we can say the lower flat plate collector are basically divided into three categories according to temperature I have discussed. So we can say the low temperature collectors, medium collectors, and temperature, then the high temperature. So in case of the low, rate between the 5 to 30 degree. In case of the medium, you can say that is the 15 to 200 degrees centigrade, and in case of the high temperature is more than the 200 degrees centigrade. So you can say the low temperature solar collector are typically unglazed flat plate collectors and intend to the operate the temperature only 5 to the 30 degree and above ambient temperature. And the low temperature liquid collectors are used the swimming pools heating, swimming pool heating, and with the light glazing and include they are, you can say, used the air collectors for the agriculture low temperature applications such as the crop drying. Second is the medium collectors are used, you can say the flat plate collectors include in this insulated case, and which one one with one or two glazing, and the intent to temperature to range operation is the 15 to 200 degree Fahrenheit above the ambient temperature. And we can see the for the Lower end of this range, you can say the single collector and non-selective observer plates are most selective. And in the middle, high and high end, the other range, you can say the selective collectors with one or two glazing becomes more cost effective. So the typical application include the water heating, space heating, and some the medium temperature industrial heating gases for the heating usage. And the high temperature, you can say the flat plate collector use, and in this case, the basically you can say heavy insulation is there. The selective observer plates and heavy insulation, and may have a temperature capability enhancing and installation by being the mounted or the sun tracking system. So these are the three types of the category of these flat plate collectors. So solar cells, you can say the flat plate collectors have the following advantage and over the types of solar energy collectors. So absorb directly, diffuse and reflected components of solar radiation the fixed in tilt and orientation, and thus there is no need to tracking for the sun, and easy to make and low in the cost, comparatively low maintenance cost and life long life by the mistake of life, operating and comparative high efficiency. So solar power generation, you can see there are two type of solar power generation. uh, there are two main way of generating the energy from the sun. One is the photovoltaic that convert the sunlight directly into electricity, is the PV, and second is the CEST. So concentrating solar thermal. So PV is convert the directly. You can convert the sunlight to direct to the electricity, and here the generated electricity indirectly. So these are the two type of, we can say, the generation of the power. So next in the lecture I'll discuss between the what is the solar photovoltaic and concentric solar thermal system. We'll discuss in the next lecture. So thank you so much. If you have any query, so you can just mail me on my mail ID, the Pratap@akgec.ac.in.